Today we're talking about linear inequalities with only one variable. We're going to talk about quadratics tomorrow, but today's linear inequalities with one variable. Something that is very, very, very important that you guys have to remember, okay? You're going to use the same rules as we did with equations, but you have to remember when you are dividing or multiplying both sides of the equation by a negative number, what do you do with the inequality sign? When you multiply or divide by a negative, what do you guys do with the inequality sign? You flip it. If you do not remember to do that, your answer will be incorrect. So you guys have got to remember. If you need to get into the habit of saying, did I multiply or divide by a negative number? Every single time, then do that. Because when you multiply or divide by a negative number, you have to flip the inequality sign. All right? Your answers can be written as an inequality statement, a graph, and we're going to talk about interval notation today, right? From now on, interval notation is how you're going to write things. So that's what you're going to use from this class on in math. Everything's going to be an interval notation, not just like everything less than 8 or something like that. So we'll talk about that right now. Okay, when you are talking about less than or greater than, okay, we have to know what that means, which direction we're going, that sort of a thing. Greater than means bigger, less than means smaller, correct? All right, let's talk about some notations here. I'm going to call, that's not a great circle, but I have an open circle and a closed circle. Does anybody know what the difference is between those two things? One is open and one is closed, correct. Does anybody know what they mean? Tell me.
One of them is like not including the
correct. A closed circle, right? This is closed. Why is it closed? Because it's colored in, and this is going to be an open one. So a closed circle means or equal to. So greater than or equal to, less than or equal to. Open is greater than, less than. It's not or equal to. A closed circle includes the value. An open circle does not. Okay, do you guys understand what I mean by that? If something is included or not included. All right, now we're going to talk about interval notation. When we have interval notation, if you have an open circle, you use parentheses. If you have a closed circle, you use a bracket. Okay, these are brackets. And these are parentheses. P-A-R-A-N-T-H-E. I think that's close. So we are going to graph on a number line today. You're going to graph on WebAssign. You got to play with a little bit. An open circle and a closed circle. Closed means it includes or equal to. And when you do interval notation, we're going to use brackets versus parentheses. Now, another thing I want to talk to you guys about. Over here on your x-axis, this is negative infinity. And over here is what kind of infinity? Positive, okay? We always use parentheses on our infinities. Because you can never include the end of infinity. You can never say, well, this is where it stops. It includes this last number. Because is there ever a last number? No, it goes on forever and ever and ever. So anytime you have an infinity, whether it's the negative infinity or the positive infinity, we're always going to use parentheses. And this is going to make sense in a second. How do you read a graph? How do you read a book? From what direction?
Left to right.
Left, good. To right. So we're going to get in the habit of using our interval notation here, our big kids. And once I do a couple of these, it'll make more sense once we get through here. Does everybody have all this stuff written down?
No.
Okay. Yeah? Okay, no, you're fine. Let's do some examples here. All right, we're solving, graphing, and putting an interval notation. We're going to do 3 different things. So the first thing I want to do is I want to solve this. Just treat it like it's an equation. When we have an equation, we want to get letters to the one side, numbers to the other, right? When you have an inequality, the best place for the variable to be is on which side? The left. That's where we're used to seeing things. So let's go ahead and solve this inequality. What am I going to do to both sides? Subtract 3x and add 7. Okay, perfect. So 5x minus 3x is 2x. 7 cancels. What does that sign say? Greater than, good. 9 plus 7 is 16. Now I'm going to divide by 2. What am I dividing by? 2. Is that positive or negative? Positive. So do we have to flip the sign?
Yeah.
No, only if it's negative. You only flip if you divide by or multiply by a negative. So x is greater than 8. All right, now think about this. X is greater than 8. That's our inequality statement. We're now going to graph this on a number line. All I need to see from you guys is 0. And then where would 8 be? To the right of 0 or to the left? Okay, so 8's over here. What kind of a dot am I going to put at 8 if it's just greater than? It's open. This is an open circle. Does it include 8? No. And then which way are we going to shade if it says x is greater than 8? To the right, okay? So like this. There's your shading. Now we're going to write an interval notation. So remember, this is negative infinity over here. This is positive infinity over here. We read left to right. So where do my values start? At what number? At 8. And it goes to what? Positive infinity. Now what goes on the ends? That's really important here. What goes on the end of infinity? Parenthesis. And what goes on the end of 8? Why is this a parenthesis? Because 8 is not included. If the dot was colored in, what would your notation be on the end of 8? A bracket. All right, does everybody understand that? So there's 3 parts of your answer here. Here's your inequality statement. Here's your graph. Here's your interval notation. We're just going to go through a bunch of these and just do that. Then we're going to go to some absolute values. Everybody okay? All right, let's go to number 2. Again, just a linear inequality. What does it mean if it's linear? X is to what power? To the first power. Good. So let's move our x's to the left and our numbers to the right. So minus 2x and plus 3 on both sides. You guys agree? 7x minus 2x is 5x. 3's will cancel. Less than or equal to. 7 plus 3 is 10. Now I need to divide by 5. Did I multiply or divide by a negative number? No. So my sign stays just like that. And 10 divided by 5 is 2. All right. There's our first part of our answer, our inequality statement. Now we're going to graph it. All I need to see is 0 and then the value that we're looking at, which is 2. Where is 2? To the right or to the left? To the right. So here's 2. Now what kind of a circle do I need at 2? Why is it closed? Because it's got that or equal to sign underneath. Perfect. And it says I want x less than or equal to. Where are all the values less than? To the left. Good. And then we're going to write our interval notation. Remember, we always read from the left-hand side to the right-hand side. So where do the values begin on my number line that I can use to satisfy this inequality? Negative infinity. And it goes all the way up to what number? 2. Now tell me the notation. What goes on negative infinity? On negative infinity. It's going to be a what? Parenthesis. And what's going to go on to? Close bracket. Good. Why is it closed?
Because
it's included. Good. So here's my number line. Here's my interval notation. What always goes on negative or positive infinity, guys? What notation always on negative and positive infinity? Parentheses. Because we read from left to right. So you're starting at negative infinity and going, oh, it stops at 2. Yeah.
So for the x, like how would you get it to like infinity? Because it says x there and then you go down infinity.
It says x is less than or equal to 2. So all of the values that are less than or equal to 2. So we read left to right. So it's anything from negative infinity all the way to 2.
So those would be the 2.
Those are your, yeah. We always read left to right. All right, let's look at this one. This one is immensely so much harder because what? There's a fraction. So therefore we're like, oh my gosh, we can't do it. All right, what's something easy that we could do just looking at this to make this problem a little easier? What's in front of my x on the right-hand side? What's in front of my x on the right-hand side? Right here. There's a 1, right? What's another way I could write 1 so it might make my problem a tad easier when I move from one side to the other? Could I write this as 2 over 2? Sure. Do you have to do that? No. I'm just saying, because we're going to move x's to the left and numbers to the right. So when I move my x to the left, I'm going to subtract 2 over 2x, right? Do you guys agree with me on that? So all I did was just change one whole to 2 over 2. And then I'm going to go ahead and subtract 1 from both sides. So my 1's cancel. What's a negative 3 halves minus 2 halves? Negative 5 over 2x. Good. Greater than or equal to. What's negative 4 and negative 1? Negative 5. Okay, good. We okay? All right, now, I need to get x by itself. If I multiply both sides by 2, okay. What else could I multiply both sides by? Okay, what else could I multiply both sides by? 2/5, right? Could I go ahead and just flip it? Either way, you guys want to do that. You can multiply by 2, negative 2, whatever. We're going to have to simplify a little more. If you guys want to just go by 2, that's fine. If I multiply this side by 2 and this side by 2, you guys agree? We're okay? So I have negative 5x greater than or equal to what? Negative 10, perfect. If you would have done negative 2, that would have worked. What would you have had to do with your sign? Flip it, okay? At some point, we're going to have to. Yep, multiply or divide. So now my next step is I'm going to divide both sides by a negative 5. Guys, when you multiply or divide by a negative, what happens? Your sign flips. This becomes x is less than or equal to what?
2.
Positive 2. Now again, you could have multiplied both sides by 2, both sides by negative 2, both sides by 2 over 5, both sides by negative 2 over 5. You would have arrived at the same answer. You just would have had to have done your simplifying at a different spot somewhere in there, but it would have been fine. So there's my first part of my answer. There's my inequality statement. So now let's graph it. Very basic graph. I have 0. Here's 2. Think about what kind of dot do you have at 2? Why is it closed? Because it's or equal to. Good. And when I read that, it says x is less than or equal to. So which way am I shading? To the left. All the stuff over here is less than or equal to. Good. So there's my graphing. Now I'm going to write my interval notation. We read left to right. So where do the values begin that I can start using? Negative infinity to what? To 2. What goes on to? A bracket. Perfect. Why is it a bracket? Because it's or equal to. It's included. How we doing? Because you start from the left-hand side and go to the right-hand side. So it's everything over here. We always read left to right. Right, again, I have a fraction. If you guys want to right away, what could I change my 1x to on the right? I could change it to 3 over 3. If you want to do that, great. If you don't want to, fine. I just kind of see, oh, I can make one whole into a common denominator to make my life a little easier. But let's move our x's to the left and numbers to the right. So I'm going to subtract 3 over 3x. And I'm going to subtract 2 from both sides. You guys agree? Okay. So my 2's cancel. What does this leave me with on the left? Negative 8/3 x greater than or just greater than, sorry. Greater than or what? Greater than negative 8, sorry. All right, same exact problem as we just had. I got to get rid of the 3. What do? Multiply both sides by? Watch, I'm going to do something different. I'm going to do what I said before. I'm going to multiply both sides by 3 over 8. Am I allowed to do that? Yeah, sure. So what am I left with on the left-hand side? What kind of x? Negative x, okay. Greater than what? Negative 3? Is that okay? What do I need to do? I need to divide both sides by negative 1. So this becomes what? X is less than 3. God bless you. If you would have multiplied both sides by 3, you would have gotten negative 24. Then divided by negative 8, you would have gotten 3 as well. It doesn't matter. As long as mathematically it makes sense, it's fine. But you just got to be real careful with that negative sign. So here's my inequality statement. Let's go ahead and graph it. Here's 0. Here's 3. Tell me what my number line looks like. Open circle at 3. Good. X is less than 3. Which way am I shading? To the left. There's my graph. Now, what is my interval notation? From where to where? Negative infinity to 3. And what goes on the end of both? Parentheses. Does not include 3. And negative infinity or positive infinity always has a parenthesis because there's no ending point. How we feel? Okay, good job. Scooting along, okay? Now we're going to do something a little different. Does anybody know how to solve these or how to attempt to solve them when you have x in the middle? All right, well, we have to be fair. What we do to one side of the equation, we do where? To the other. So what we do to one side of the inequality, we have to do where? To the other, okay? So I'm trying to isolate x. I want x by itself in the middle. So what's the first thing I'm going to do here? I'm going to add 2. So if I add 2 here, and I'm going to add 2 over here. You guys agree? Okay, so negative 4 plus 2 is negative 2, less than or equal to 5x. This cancels, and then less than what? 9, okay. Now, how do I get x by itself? I'm going to divide by 5. Well, what I do to one side of my inequality, I have to do where? To the other. So I have negative 2/5 less than or equal to x less than 9/5. Notice where x is. It's in where? It's in the middle. Okay, so think about that. Here's my inequality statement. So now I'm going to graph. Here is 0. Where is 9/5 and where is negative 2/5? 9/5 is on the right. You guys agree? Where's negative 2/5? On the left. Whoops. I don't know why I remember 3. Okay, so what kind of a dot do I have at negative 2/5? Y. Or equal to, good. And then what kind of a dot do I have at 9/5? Open. And then where is x, guys? Where is x in compared to those two numbers? In the middle. So where do you think I'm going to color? In the middle. There you go. Now, how do I write this interval notation? Tell me. No, where does it start? Where do the values start that I can use? Negative 2/5. And where do they stop? At positive 9/5. What goes on negative 2/5? Bracket or parenthesis? Bracket. And then what on 9/5? Perfect. Good. You don't you have a specific starting and stopping point when x is in the middle. So you're going to have a stopping and a starting. You're not going to have negative or positive infinity.
How do you put the parentheses on the 9/5 and not the negative 2?
Because this is open. It doesn't have the or equal to. And this one is closed because it has the or equal to. Good question. All right, let's look at number 6. Again, kind of look at things before you guys start. Where is x? It's in the middle, all right? So think about that. When you graph and all that stuff, think about where x should be. So I want to isolate x. What would I do first? I'm going to plus 1. So if I add 1 here, then I have to be fair and do it everywhere. So what's negative 3 plus 1? Negative 2. All right, less than or equal to 6x. That cancels. And then I have less than 4. Okay, now I want x all by itself. So what am I going to do? Divide everything by 6. Perfect. Good job, guys. So this becomes negative 1/3 x. And then what? 2/3. Okay, there's our inequality statement. Perfect. So let's graph it. In regards to 0, negative 1/3 is to the left and 2/3 is to the right, correct? What are the dots? Close where? Close at negative 1/3 and open at 2/3. Very good. So what does my interval notation look like? Bracket, negative 1/3, comma, 2/3, what? Parenthesis. Good, very good. Oops, I forgot to color. Thank you. Right, it's not crazy hard. It's different, but it's not crazy hard. All right, take note. Where is x? In the middle. So what do we want to do with x? We want her to be all by herself. Poor things. What am I going to do? First thing. Perfect. Subtract 7, subtract 7, subtract 7. So 1 minus 7 is negative 6. This will cancel, correct? So I have 2x there. And then what's 11 minus 7? Perfect. Now what? Divide, divide, divide. So negative 6 divided by 2 is negative 3. 2 divided by 2 is x. 4 divided by 2 is 2. Did I multiply or divide by a negative number?
No.
No. So we're good. Just leave it. All right. So now let's graph. Negative 3 is here, 0 is here, 2 is here. What kind of dots do I have? Open, open. Agreed. So I color where? In the middle. Good. Because x is in the middle. So what's my interval notation here? Perfect. Perfect. Proud of you guys. Doing great. Yes, more fractions. Where do you see x? In the middle. Okay, so let's get her all by herself. So I'm going to subtract 2/3 from everything. I'm going to go ahead and change negative 4, in 2/3. What would that become? Negative 12 over 3. Do you guys agree? Yes or no? And I'm going to go ahead and change positive 5 in 2/3. What is that? 15 over 3. Okay, let's just go ahead and do that now so we can see this. So I'm going to subtract 2/3 from both sides of my inequality. So negative 12 minus 2 is negative 14 over 3, less than or equal to what? Negative x less than what? 13 over 3. Perfect. All right. Am I done? What's the problem here? X is negative. We don't want that. So I'm going to divide everything by a negative 1. Guys, if you divide by a negative, what happens? Your sign flips. So negative divided by a negative gives me 14 over 3 greater than or equal to x greater than negative 13 over 3. Does everybody see what just happened there? When you multiply or divide by a negative, the inequality sign has to switch. So there is your inequality statement. Now let's go ahead and graph this. Now don't get confused, guys. Don't put 14/3 on the left and negative 13/3 on the right, because that's not the case, correct? Negative 13/3 is going to be smaller than 0. Positive 14/3 is bigger than 0. What kind of a dot do I have at negative 13/3? Open. And what do I have at 14/3? Close. Good. Parenthesis, negative 13 over 3. Good.
And 14 over 3 close.
Perfect. Very good. Okay, awesome. You guys did great. We're not done.
Yay.
We're not done. Now we're going to do the exact same thing, but we're going to solve what? Absolute value inequalities. All right, you guys, we're going to do it the same exact way we did this yesterday when we solved equations. We're going to do the exact same thing. You're going to isolate the absolute value. This is a little trick if you want to think about this. But if the absolute value is, what does that sign say? Less than, right? This says less than or equal to, correct? What does the bottom one say? Greater than. Okay, so think about this. Less than, all right? Less than becomes an and statement. What that means is x is going to be where? In the middle or in the outsides? Where are we going to color? Let's say that. Where are we going to shade? In the middle or on the outside if it's less than? Middle. Good. And then greater than, this is going to be an or statement, which means you're going to color on the outsides. You'll see what I mean by that in a second. Do you have to remember that? No. But it's something to think of. So we're going to solve the exact same way we did yesterday. I may not get through all of these, which is fine. So look at number 9. I have absolute value of x minus 5 is greater than 2. I'm going to go ahead and circle this. Is there anything being added, subtracted, multiplied, anything to that? No. Okay, so it's isolated. So we're going to do what we did yesterday. I'm going to rewrite this 2 times. I'm going to say x minus 5 is less than 2. And then I'm going to solve it again, and I'm going to say x minus 5 is greater than negative 2. Because when you are changing the sign, you're actually multiplying by a negative 1. Or dividing by a negative 1, either way. So when you rewrite your absolute values, you flip the sign and change the sign of the answer. So let's go ahead and solve this. What are we going to do to both sides? I'm going to add 5, so I get x is what? X is what? Okay, less than 7. And over here, I'm going to add 5 again. And I got x is greater than what? 3. Okay, there's your 2 inequality statements. So now we're going to graph it. Here is 0, here's 3, and here's 7. All right, what kind of dots do I have at 3 and 7? Both open. Now think about this. I want all this stuff where x is greater than 3, which would be this direction, right? And then I want all the stuff where x is less than. So where do they intersect? Where do they have overlapping? In the middle, right here. So how would I write that as my notation? What is my interval notation? Parenthesis, 3 to what? To 7. Now think about this, guys. What does this sign say? This is a less than. On that slide we had before, less than is going to be what kind of a statement? An and statement, less than. Is this an and statement? Did we color in the middle? Are we between here and here? Yes. Let's look at number 10. All right, isolate. Is my absolute value all by itself? Okay, what kind of a sign does this say? Greater. I'll show you what that means in a second. So let's go ahead and rewrite this 2 times. I have x plus 3, just exactly how you see it, greater than or equal to 7. And then I have x plus 3 is what? Less than or equal to? Negative 7. Perfect. So solve. We're going to subtract 3. X is greater than or equal to 4. Over here, I'm going to subtract 3 again. And I have x is less than or equal to negative 10. Okay, there's your 2 inequality statements. So let's graph it. Here's negative 10, 0, and 4. What kind of dots do I have at both places? Good. Now read what this says. X is greater than or equal to 4. So 4 or bigger. That goes this way. And then the other one says x is less than or equal to 10. So everything's smaller. So what is our interval notation going to look like? Let's talk about this for a second. What values are included? Well, we start on the far left-hand side. I start with what? No. I start over. All of this stuff can be used. So negative infinity up to what number? Negative 10. Can I use anything past negative 10 up to 4? No, there's a big gap. Do you guys see that big gap? All right, so you're going to have something called a union. But what goes on the end of negative 10? A bracket, good. Now there's a big gap. When we say, oh my gosh, there's a big gap, you put a big U. That's like saying and in math. This and this. Where do my values begin again? 4, and they go all the way up to what? Positive infinity. What goes on infinity? Parenthesis. What goes on 4? Bracket. Do you guys see the difference between an and statement and an or statement? All right, and it's going to have from one number to the other. X is in the middle. Those were an or statement is going to be this side or that side.
So you put or for this?
No, you don't. I'm just saying that's an or statement. You don't have to write or. No. All right, let's look at number 11. Okay, isolate. Is it by itself? All right, what is my graph going to look like here? That says x, absolute value of x minus 20 is, does that say greater than or equal to or less than or equal to? It says this is an and. All right, this is an and statement. I know it's and because it's less than, okay? So let's go ahead. X minus 20 less than or equal to 4. X minus 20 greater than or equal to negative 4. Agreed? Okay. So I'm going to add 20 to both sides. X is less than or equal to 24. I'm going to add 20 to both sides. And x is what? X is what? Greater than or equal to 16. Okay? So there's our 2 inequality statements. Here's 0, 16, 24. What kind of dot do I have at 16? Close. What do I have at 24? Also close. Good. So let's read our inequalities. I want all the stuff that's less than or equal to 24. So So that's everything this way. And then I want all this stuff also that is greater than or equal to 16, which is this way. So where do they overlap? In the middle. This is where they overlap here. So what does my interval notation say? Bracket, good. 16 to 24, good. And I close my bracket. Very good. You guys are doing great. You're doing great. Mm-hmm. Yeah. All right, let's look at number 12. How's 12 a tad bit different? X is not by itself. Very good. You cannot determine your and or statements until that is isolated. So let's go ahead and isolate the absolute value. What would I have to do to isolate my absolute value here? I'm going to divide both sides by what? I'm dividing by what? I'm dividing by a what? Negative. What's going to happen here? I have to flip the sign. What's negative 15 divided by negative 3? 5. Now that your absolute value is isolated, can we figure out what kind of a statement we're going to have here? Look, we're isolated. So is this going to be an and or an or? It says x minus 1 is less than. This is an and. You cannot determine what it's going to be until you have your absolute value isolated. Got to have it isolated. So once we have that, let's just go ahead and solve like we've done all of the last of them. So I have x minus 5 less than x minus 1 less than or equal to 5. And then I'm over here, I have x minus 1 is going to be greater than or equal to what? Negative 5. Good. We flip the sign and the sign. So I'm going to add 1 to both sides. I have x is less than or equal to 6. I'm going to add 1 to both sides, and I get x is greater than or equal to what? Negative 4. Okay, there's my two inequalities. Good. Here's negative 4. Here's 0. Here's 6. What kind of a dot do I have at 6? Close. What kind of a dot do I have at negative 4? Close. Right, now let's think. The first inequality says all this stuff less than or equal to 6. So that's everything this way. My other inequality statement says all the stuff that's greater than or equal to negative 4. So that's everything this way. Where do they overlap? In the middle, in here. So what does my interval notation say? Bracket, negative 4, comma, 6. Close that bracket. Good. Is this an and statement? Yeah. But we couldn't tell that until we isolated. Does that make sense? Alrighty. Okay, let's look at 13. Is my x minus 1 an absolute value? Is it isolated? No, so let's get it isolated first. We're going to divide both sides by negative 2. So I have the absolute value of x minus 1, what? Greater than or equal to negative 2. Why did the sign flip? Because we did what? We divided by a negative. Okay. Everybody all right? What kind of a sign is this now?
Greater than or equal to.
So it's an or, right? Or. It's going to be one or the other, okay? So let's go ahead and go through our process of solving. X minus 1 greater than or equal to negative 2. And then I have x minus 1 less than or equal to positive 2. Agreed? Yeah. Okay. So I'm going to add 1 to both sides. I have x is greater than or equal to negative 1. Add 1 to both sides. I have x is less than or equal to what? 3. Everybody with me? Okay, so let's go ahead and graph. Here's negative 1, here's 0, here's 3. What kind of dots do I have at negative 1? Closed. And what do I have at 3? Closed. All right. So I want all of this stuff that's greater than or equal to negative 1. Yeah? Okay. So everything over here. Then I want all the stuff that's less than or equal to what? 3? Over here. Everybody agree? Okay, so where do I graph? I mean, what's my interval notation?
Bracket,
-1 to 3. But you guys told me at the beginning that this was an or statement after we got it by itself. So shouldn't it be this or that? What do you guys notice right here? Look at that. Tell me something. Anybody notice anything? Talk to me about absolute value. Absolute value is always what? Positive. Is there ever a time that this statement is going to be untrue? When? When is the absolute value ever going to be equal to -2? It can't be. Is there anything, so there's two solution or two possibilities for this. You can tell me there's no solution, there's no values I could use, or you could tell me it's every value I can use. What is this case?
No value.
Absolute value is always what, guys? Positive. No matter what I put in for x, because it's an absolute value, is this always going to be greater than a negative number? Yes. So in this case, look, we followed all the rules. We figured out once we isolated that this should be an or statement. But then when we went to graph it, it turned out to be an and statement. Right there, that's telling you, ooh, this is one of those special cases. Let me go back and look. It's not just -1 to 3. It's any number in the world that I could plug in here, because what's going to happen if I plug in any number in the world? The absolute value is always going to be what? Positive. So this is one of those special cases where you can use any number. If you know this little trick of, okay, once I isolate absolute value, this is going to become an or statement, and then when you get to the end, it turned into an and, that should tell you, oh, wait a second, let me just look. Let me see if this is a special case. And then we look here and we're like, oh, wait a second. When you guys got to that step right there, you could have stopped and told me -infinity, +infinity. Because the absolute value is always going to be greater than what? A negative number. Always. It could be equal to 0, but it cannot be less than 0. Does that make sense? All right, I'm going to do 16. I'll finish 14 and 15. They're similar cases. I'll do it in a second, but I want to do 16 before class is over. All right, just look at this for a second. Don't even read this. This just says absolute value, okay? Think about absolute value. Absolute value is always what? Positive. So this is saying the absolute value is greater than 0. Is that true? Yes. If it was greater than or equal to, that will always happen, correct? This is a little different. I'll show you why in a second. All right, so is my absolute value isolated? Yes. Okay, so let's go ahead and solve it. 2x minus 1 greater than 0. And then over here, I'm going to have 2x minus 1 what? Less than, is there such thing as a -0? No. So we just keep it as 0. So if I go to solve this, I'm going to add 1 to both sides. 2x is greater than 1. Divide by 2. X is greater than 1/2. Yeah? So over here, I'm going to add 1. I have 2x is less than 1. Divide by 2. And x is less than 1/2. Agreed? Yes or no? Okay. So let's go ahead and graph this. Here's 0. Here's 1/2. What kind of a dot do I have at 1/2? Ooh. It shouldn't be. Yeah, that's my bad. What kind of a dot do I have at 1/2? Okay, so let's think about this. My first inequality on the left says I want all the stuff that's greater than 1/2. So you guys agree it's this way? Okay. My second inequality says it wants all the stuff that's what? Less than 1/2. So this way? Is my answer here all the numbers in the world? -infinity, +infinity? Can I use every single number on that number line? No. What can I not use? Why can I not use 1/2? Because it's not or equal to. So what would your interval notation be for something like this? Parenthesis. Nope, we left to right. We read left to right. Negative infinity to?
Infinity.
Nope.
1/2.
1/2. Does it include 1/2? No. So then there's a gap. Where does it pick up again? On the other side of 1/2, right? So 1/2 to what? Positive infinity. You can use every single number in the entire world except for 1/2. If this was or equal to, hold on one sec. If this was or equal to, what would your answer be? Negative infinity to positive infinity. Good. You're going to, every now and again, guys, you'll have one of those little tiny nuances. I'll do 14 and 15 during my lunch, and then when I upload this video, so it'll be there. But every once in a while, you'll have one of those little nuances, so you have to pay attention to that. Mia asked, you have to have the U. If there is a gap, like if there's a break in your infinity, if it's this or this, yes, you have to have the U. That's bringing the two together. It's saying this or that. Good question. Okay, let's go back to 14 and 15, because I did not get to those in class. I wanted to make sure I got that last one. So let's just do 14, 15, and then we'll be done for this. Okay, is our absolute value isolated? Yes, so let's determine what kind of a inequality you have here, an and or an or. This says x minus 1 less than, so this is an and problem. So we're going to say x minus 1 less than or equal to 0, and then we're going to say x minus 1 greater than or equal to negative 0, which is just the same as 0. So guys, we're going to add 1 to both sides. So x is less than or equal to 0. I'm sorry, 1. And we're going to add 1. And we have x is greater than or equal to 1. So remember, an and means where they overlap. So here is 0, here is 1. What kind of a dot do we have at 1? It is going to be closed because it's or equal to. Good. So my first, my first inequality on the left says x, everything less than or equal to 1. So it's all this stuff over here. My second inequality says greater than or equal to 1. So it's this stuff over here. But where is the only intersection that we have here? Because that's what that's going to be our solution. The only intersection point we have is right here at x equals 1. This is one of those special cases. The only value that will satisfy this inequality is where x equals 1. Because think about it, absolute value is always positive. Always positive. And this is saying, when will the value over here, which is always going to be positive, be less than or equal to 0? Well, it'll never be less than 0. It can only be equal to. And the only time it'll be equal to is when x equals 1. All right, this is the same type of a problem. This is if our absolute value is isolated, which it is, this is a less than problem, less than. So we can go ahead and solve. 2x minus 1 is less than or equal to 0. Then we have 2x minus 1 is greater than or equal to negative 0, which again is just 0. So we're going to add 1 to both sides. 2x is less than or equal to 1, divide by 2. X is less than or equal to 1/2. Again, we're going to add 1 to both sides. 2x is greater than or equal to 1, divide by 2. X is greater than or equal to 1/2. So if we're going to graph this, remember, and means where they intersect. So here is 0. Here's 1/2. What kind of a dot do we have at 1/2? Well, it's going to be closed because it's or equal to, it's included. So here I'm looking at x is less than or equal to negative 1/2. So that's from this point, everything over here. And then I look at my next solution and it's greater than or equal to, so it's from this point and then everything over here. Where is the only place that there is an intersection? It's at x equals 1/2. So if you think about it, guys, again, this is absolute value is always positive. So if you're looking for the place where the absolute value is, that's going to be positive, is going to be less than or equal to 0. It's only at one specific point, because it'll never be less than 0, but it could be equal to. Okay, all right, that's this lesson. Make sure you guys are practicing. Do as much of your web assignment as possible. Come in and ask questions, and we'll move on to the next lesson tomorrow.